then let's continue with some philosophy about cloud native. Let's see. The stream is okay? Yes. Okay, perfect. So today I will rerun one of the talks that I did 3 weeks ago when talking about this kind of learning by making a presentation. This was also one of them because I ran into a person from the TI KV project, one of the graduated CNCF projects, which is TI KV is a distributed key value database. So I ran into that guy at KubeCon, and then we started talking. I had some use cases for this project. We spoke some more, and then one thing led to another, and then I was like, let's go to their conference in Mountain View, California, and let's have me learn some more about distributed database design. So this is what I came up with, and and it also relates to my bachelor thesis work 2 years ago, where I, after having contributed quite a lot to Kubernetes and written some of the Kubernetes parts of the project, I started thinking that, okay, so I have implemented a lot of, or some of the specifics of how Kubernetes works, but why did we do it that way and not some other way? Why did we choose one thing over the other when making a design decision? Most of the design decisions in Kubernetes turned out to be really great. Of course, no one gets ever 100% of the hits on target, but like most of them went well. And I started thinking when writing the thesis, like, why did it actually work this kind of way? So this is what these two questions I will kind of put together. So like how to manage databases at scale, together with why did Kubernetes actually work, because they actually have the same reason. So a little bit about me. I'm Lucas, studying the first year at Master's, studies at Alta at the moment, but actually my studies don't relate to anything CNCF. That is all what I've done besides the studies. Been speaking at some KubeCons and was active contributor to Kubernetes for many years. So if you've used, for example, Minikube, Kind, or KubeADM for installing a Kubernetes cluster, or any of the cluster API things on top, then I'm sorry to tell you, you're running my code. So don't don't at me when it breaks. During that time, I was working for a startup called WeWorks as well, which funded the open source kind of Kubernetes contributions. And now at the moment, I'm doing some, besides my studying and like consultancy company with Kubernetes things, then also active in the Guild of Automation and Systems Technology as a head of corporate relations for the students. So what we'll talk about. And as you see, this is for the theme and everything is for that conference that I presented it. I didn't change it for this, but yes, we'll talk about database sysadmin complexity. So I think that, or how many of you have ever managed a database, in one form or another, run MySQL or something like that? Oh yeah, so there's some, we should be on the same page here, right? We start a rant about that, right? So how that can be hard sometimes, and then we'll go into why, like, how is Kubernetes? What does Kubernetes architecture look like? And then we'll go to one of the solutions to that first stated problem, and the second design. Then we'll look at the specific implementation of that, the TIDB implementation of that, and then I know I won't have time to actually make a demo, but I did a demo before and then took screenshots of it. But we'll see. It's quite cool, but it takes 15 minutes, so I don't have time for that during a 30-minute talk. So now, well, this again. At the conference, we were there for talking about both transactions processing and analytical processing of data. At this meetup, we are talking about that and much more generally as well. But if we have something that that wants both kind of the ability to do transactions that are frequent, small, and latency sensitive, and stuff like analytical processing when we want to get a lot of historical data over a long time, we have a couple of requirements, right? We need failure tolerance, and kind of there's also a lot of demand for capacity. We can't put everything on one node once the data grows large enough. So we need to have multiple nodes, okay, multiple machines. When it's one machine, still things are quite complex, but I mean, at least it's way easier than when you're already going from 1 to 2 or 3 machines. The complexity goes more than exponential, because when we have multiple replicas, then we need to have some kind of mechanism for consistency control. If we want to have something like strong consistency, so that you know that you always will read your write, for example, when in the default way of MySQL, some leader follower configuration, you won't necessarily read the write you just put. But in some kind of strong consistency control like Paxos or Raft, you will. But that is, it's consistency control is complicated. In fact, you need quite deep understanding of special relativity even to make sense of such a protocol. Then when capacity increases, we need sharding. Okay, so and here, reference to these, there is the Google paper about Percolator, and which is the database they use for the search engine index, and the Spanner paper about their globally consistent SQL-like database where they actually use atomic clocks in order and GPS in order to kind of get the the consistency right. So you know that you will, even though you are in I don't know, Singapore, and you read at some specific instance in Singapore, then you know that somewhere else, if you read after that, then you will actually read that right that you put in some other place. It's an extremely hard problem, especially that light speed it's fast but finite. So so there will always be some latency, and that stuff really starts crippling down in these problems once you kind of look at it deeply enough. So we have multiple nodes. We need some scheduling logic. Okay, fair enough. We have a consensus algorithm. We need to take care when scaling. If we have some kind of, we have say 3 replicas, and then we want to add 2 more. Then we cannot have the 2 new ones start serving data like this, because it takes, again, light speed is fast, but there will always, in order to get gigabytes of data or terabytes of data to those new places, it is taking some time. So we need some kind of learner mode to do that. So first, the new replicas will be in the learner mode, and after that, they will actually be ready to start serving requests. So they're alive but not ready. But then when upgrading, if we have some kind of leader protocol, or Paxos and Raft both have one leader, and if we kill the consensus leader, it's not that bad. They will do a re-election, but I mean, you will see when it kind of drops in performance. So, but if you give a proper handoff first, then you will have a much nicer time when upgrading. Then sharding, you will have non-uniformity of data for different replicas, and all of these kind of stuff. Business requirements are for sysadmins usually changing pretty quickly, especially as the data amounts grow and this kind of stuff. So there's a lot of sysadmin work. So all in all, you get to this place where it's not that easy of a challenge to operate a database in production, which should be, again, to you, pretty obvious. But the more general takeaway is that in order to operate any non-trivial system in production, you actually need non-trivial operations. And this also seems quite obvious, but it's not sometimes kind of accounted for in, say, project timelines and deadlines and new roadmaps and stuff like that, that usually you think it's the same thing as going from 3 to 5 nodes as from 5 to 7 or something like that, or it's the same thing as going from 1 gigabyte to 10 gigabytes, the same as 100 to 1,000. It's not necessarily. If we get ourselves on the wrong side of this curve, we will have a hard time. So now take a look at like what is some of the things that we can do to solve this, and what are some of the things that cause this. So Kubernetes actually had this very same problem, and I know I already talked about Kubernetes. If you don't know what it is, then it's an open source container orchestration system. It is at core a thing to solve the sysadmin operational challenges of application orchestration. So like you have to Kubernetes, containers are just an implementation detail. They're really not that important in the bigger picture. Kubernetes cares about applications. And it's about the say abstract problem of you have an app, you have some multiple nodes, and how do I map these between each other? That is a kind of the problem statement, right? And especially as how do I, as a sysadmin, need to kind of take care when these kind of things change. That is what Kubernetes is, set to solve. How it does it, the solution space is vast, but and containers is used, like all kinds of load balancing and DNS and whatnot. But that is what it's at its core. It's already almost a decade old. Time flies, really. It's a founding project of CNCF that I said, and if you're in this community, go into these KubeCons and if you find a bug in Kubernetes, report an issue on GitHub. There's 80,000 contributors to Kubernetes already, and if you find a bug, report it on GitHub, then hopefully you would also solve it. I mean, anybody can do that, and I mean, there's no because it's an open source project, everyone in the world is responsible for it. So there's including you. So when you it's nice to then be part of the community that actually takes this to the next level. It can run in all environments, from data center to cloud to Raspberry Pis. The first contribution of mine was to port it to a Raspberry Pi because I didn't have any beefy machines that Google had. But I have a Raspberry Pi at home, so then putting it on that, and that is quite useful for home labs and fun tinkering things. And it's a really super extensible system. You can configure everything, and this is actually one of the things that drives most users nuts, is that like there is no one standard solution for where Kubernetes kind of has everything. In fact, you get just a small generic set of like things you can do, and then you need to plug all kinds of things. You need to plug networking, you need to plug container things, you need to plug access control, you need to plug storage. Everything is pluggable, so the whole idea is that you use some of the other CNCF projects to put them, to combine it with. This is also based on decades of experience. The first paper was from Google with Borg. Borg is their internal orchestration system, which is running the search engine, for example, and all of these things. And when they found out that, or when they started having problems with Borg's monolithic structure, then then they started looking at optimistic concurrency control in Omega, which is a very similar system, almost the same. Now, I don't remember exactly how it went, but essentially every lesson learned from Omega is then incorporated into Borg, and then every lesson learned from both Borg and Omega is taken into account in Kubernetes. So what does the architecture look like in Kubernetes? So we need one place to store the single source of truth, like what does the cluster look like? This is put in the etcd. etcd is another CNCF project. If I remember correctly, it's graduated. And it implements the Raft protocol of, so consistent, it's a consistent database, but only for key values. The Kubernetes has an API server, which takes the API request from the users, from the other components of the systems, and well, stores it in the key value database. But the REST API server doesn't contain any state. You can shut it down. You can have 1,000 of them if you like, all pointing to the same etcd cluster, and that's just how it is. Then you will have a lot of compute, but none of them have any state. All the state is in that one single database. And the idea is also that no other entity than the API server will ever talk to etcd, because that's kind of protected data. Nobody should kind of have the keys to the kingdom, because the API server then enforces all of the policy, authorization, authentication, like the defaulting, admission control. The list goes on and on. It has like long things of sets of stuff to do. But the API server is, as I said, stateless. It's declarative. So to the API server, as a user, you say that I want an application to be running. And you know, when we talked about the light speed thing, it's finite. So even if I am a user here and I tell the API server that I want this to be running, no matter how good the API server would be, it never can, at that exact point in time, it can never fulfill action. It can't put in the same set of time. It can't fulfill that. So the idea is that because we can never do anything in exactly that point in time when the user asks for it, we take a declarative approach where we first store that what does the user want to happen, and then we record that what actually is happening, because those are two different things. So that's what it means to be declarative. So we declare what is our end goal, and then it's another thing of like, are we at the end goal or not? But we store in this database, we store what the user actually wants, not what the and actually what the current state is as well. Then we have a lot of stateless controllers, which make the desired p tables and whatnot, and forwarding and everything that it will do in a controller. It looks like, oh, I don't now at the moment. I'm only running, say, 3 of the web server instances, but the user told me to run 10. So I have a quite big gap there. I need to do something. But when I'm running 10 and 10 is the actual state and 10 was asked for, then I don't need to do anything. The controller does nothing. It just waits. So the same thing for the node when method. And if you have done control theory, for example, in school, for some kind of physical project, like, I don't know, maybe when you're driving in the car and putting the auto what is it called now again in English? Now I'm blanking on the word, but you have, say, 80 kilometers an hour always. Then cruise control, yes, thanks. The cruise control is using the control theory to actually keep that all the time. Kubernetes is implementing the same control theory mechanism, but for computers and for any control, like for controlling any type of infrastructure. And now this infrastructure, as I said, just by coincidence, I mean, containers have very nice features. So they saw that containers are the way to implement this, but that's actually the upper part of Kubernetes. The lower part is this kind of whole way of structuring your application such that it's possible to do this kind of control theory things. And we need the control theory things because we cannot do anything in an instant. So Kubernetes, that is the lower level of kind of having this control theory part. That is the real innovation. The containers are just one of the possible implementations or one of the control planes you can do for specifically containers. But you could even do many different types of function as a service control planes and stuff using containers, but having a completely different API and completely different way of working. So it's a set of automated controllers. There's 45 in them in the latest release of Kubernetes. So there's pretty many implementing all kinds of different business logic requirements that take some kind of operational knowledge. So I mean, at the end of the day, there was someone when making this, at Google, there was someone that figured out that, okay, this is a good way to scale or to schedule the workloads to a node. So like to map between the set of workloads and to nodes. Someone figured out a way to do that. And I mean, they could do it, maybe at some point they even did it manually, right? Someone were doing that, but then they were like, actually I can codify this, right? So I have a controller with the operation knowledge of that person that maybe used to do it. I know how to heal applications on failed nodes. I know how to set up networking such that I can do service discovery, for example. So that is the operational knowledge that is now codified in these controllers, so you don't need a person doing it anymore. And then to control some kind of target system. So we want to control, is it containers, or we want to control some kind of storage system, or do we want to control some cloud API, or do we want to control the cruise control in the car? Do we want to control anything, DNS records or something? Then we can all do that. So this is called control through choreography. So all of the intent is stored in the API server, and all the business logic is separated into the controllers, making this a reality. So why do we have a controller-centric model? Because chaos is inevitable, and failure is the norm. And as you see, I actually came directly from my thermodynamics lecture, so there I have my physics book. Should have brought it up here, but at the moment, so the outcome of the thesis was that I know I don't know enough about neither special relativity or thermodynamics to elaborate further, so that's what I'm now studying. But failure is the norm. In their paper, they describe that, for example, leaving significant headroom for all kinds of failures and all. I think, if I'm not mistaken, it was something like 17% even that they over-provisioned because of this kind of failure. So entropy is the measure of unorderedness or orderedness, if you like. And any usual project, is it software, is it servers, is it anything, starts with an orderly. Is it universe? We started a universe with very ordered one atom or something. Now universe is quite chaotic with the arrow of time, and some go as far as they even define time as this arrow of stuff gets more unordered. So I at least find myself in these situations sometimes, that I have clean dishes at home, then I eat lunch, and then now I have chaos in my kitchen. So as time progressed, I got to the chaos state, and I could just conclude that that is the natural way of the universe. But of course, I can do something to reverse the chaos, but that actually requires me to expend energy. So the kind of idea is that it naturally, without expending energy, you get to the more chaotic part, but you need to pay energy to get it down to the kind of order which we define. But it keeps going up. So that's actually what Kubernetes is, right? So we buy a new server. It's all clean and nice. But then the arrow time makes the server see all kinds of stuff. And that's where Kubernetes comes into the picture, right? So that is the thing that day and night has these controllers that fixes the things when they break. So we need to define order and chaos. Here, I have a kind of plane, and I have 2 points in the plane. I have a person and a treasure point. That is actually telling me what. But then, when I'm actually going from place A to place B, that is an action. So that is not a state, that's an action. So and the way I go there might not be directly clear. I might go some curved paths, and the treasure position might even change while I'm walking there. Again, I can't go there instantly because then I would be faster than light. And this defining what you want to happen is very crucial, because if you don't know where you're going, like some infrastructure systems look like this. They only have the action. They don't know where they end up. They don't check what is the actual state before applying some kind of scaling action or start VM. I don't know, like, okay, I start VM, yeah, sure, but did I have any VM from before? Yeah, I actually did. Like, so not focus on the action, but focus on the place you want to become. Otherwise, it's going like Alice in Wonderland, where anything you do will actually be correct because you never define what is correct. So the key takeaway is that systems are becoming less ordered. Thus, we need some periodic corrective action to steer the course towards some declared desired state of the system. So that is what operators are. They are these controller loops which encode for example, a sysadmin knows how to operate the database, and then you put that knowledge into the code which actually follows this pattern. And then you can delegate these kind of repetitive human activities that are devoid of lasting value, as they define it in the paper. So with this, you can keep your infrastructure in control. You can have resource scalability. So you can go towards the more nodes, towards the more data, towards whatever metric you want, with less problems. Not with no problems, but with less problems. You have the monitoring scalability of knowing when actually something goes wrong or when something actually works, because you can have automated things that actually observe the application health in a much more deep way than just like, is the process running or not? You can go much more deep than that. And then knowledge scalability, if you have a super experienced sysadmin that has seen it all, in database configurations and management, then, well, how do you transfer that to the next person? Well, one way is to transfer that, actually codify that, write that down, and then the new person can actually look at that source of truth of how should you operate this application. So yeah, that leaves us essentially with this. So we avoid the overload. We get a scalable in multiple dimensions. And things can be quite nice. So it's not before the Industrial Revolution, humans were doing the kind of stuff by themselves. Before the cloud native revolution, we were managing the servers ourselves. We were, plugging the USB stick and going with the keyboard and mouse and everything. That is not where we are now. Now we are operating the automation that then operates the machines. And that is much more scalable, both for databases, for servers, for really anything, any type of infrastructure you can imagine. So yeah, I think that I have a lot more. I could go on for this for how many hours as we like, but if we now have the food, I think, or? Soon, okay, soon. Anyways, I've done my 30 minutes, so if you want to know more about this, then let me skip that part and then refer to this one. So if you want to know more about this, then you can read my thesis. It's on GitHub, Creative Commons license. So that can be some interesting further thing. Then there's many other great people that have been talking about these subjects on control theory, or you can take an engineering course. But also you can go and look at the Kubernetes, or go to KubeCon and talk to the people that have been doing this yourself. Thank you. Any questions? Or do we wait for the food?
Yeah, it should arrive in, was it 5 to 10 minutes?
That sounds good.
Was about to have the lunch, I mean the second presentation before the lunch, but I think now the plan is to have the lunch, or not lunch, but the serving first, then this second and third.
I can ask a question. You were planning to show something about TI.
Yes.
So maybe in some words tell what it makes, like what's different. Why would you use TI-DB? Is it Kubernetes native?
Yes, it is. And
Could you just repeat the question?
yes, I will repeat the question. Yeah. So the question was that can I say something about TI-DB? Is it Kubernetes native, and what benefits does it have? Well, there's a lot I could tell now. I couldn't have told you anything 2 months ago, but essentially the core idea is that what Google did with Spanner was that they built a key value store at the base layer. Or there's multiple layers. There's a storage layer for bytes or bits. Then there's a key value store on top of that, on top of the block storage, which is to which you can put keys and values like any kinds of data, but it doesn't have any SQL and these kind of stuff. But that's a kind of say logical storage layer, and it provides transactions through the raft and in Google's case Paxos algorithm, and in TI-DB's case raft algorithm. And in open source, TI-KV is the implementation of the key values store, or the kind of storage layer. So that's a CNCF graduated project which is implementing Rust, has key value features you can put to it, you can get to it, and you can do a transaction. That's all essentially. It doesn't give any SQL stuff, but that's by design. So that is a storage layer. And then on top of that, what Google did was to make a SQL layer kind of stateless, in a stateless way on top. So that they call F1. And so once you have this kind of global consistency, or strong consistency in TI-KV case, then you can build a stateless SQL server on top. So instead of having the SQL server actually include any of the data, it just queries the keys and values in transactions from the storage layer. So you can then scale the storage layer separately from the compute layer, the query layer. So when you have the query layer completely stateless, you can have, for example, 30 query engines, but they all talk to 3 storage nodes, which leads to way better scalability than if you would actually put them to be the same, and also flexibility. So there's other, there's multiple projects that are doing this based on inspired by Spanner from Google. I would say that TI-DB and CockroachDB and Yugabyte DB are maybe the ones that are the most interesting to me personally, and I wanted to investigate TIDB and KV specifically because TI-KV is in CNCF. So then kind of as this kind of neutral playground, I wanted to play with that because of that reason, and because of the reason of seeing how someone has implemented a huge, successfully huge system at Google in open source. So yes, it has. And what I was going to show there is that the operator is Kubernetes native. So you just tell it that, hey, I want a cluster with this many compute nodes and this many storage nodes, and get the storage from anywhere, like the environment. So if you're on cloud, you will get the storage from the cloud. If you're from on-prem, and then the operator handles all of the upgrading and these kind of stuff. So that is the graph here. So the key of the demo was that I specified everything declaratively. I put that in GitHub. So how do I want my TIDB cluster to look? And then I updated the version from 7.10 to 7.11. And then Kubernetes rolled that out. I looked at that. I was chilling and doing nothing at the conference. And then you can see here that I'm running 3 nodes of the storage layer. So then the operator drains them. I didn't have to know how to operate distributed database because the operator then does it for me. Drains takes it away, starts the learner mode, all this kind of stuff. And gradually, well, here you can see from the storage use as well, like it's taken away and comes back. And while I put a 60,000 requests per second SQL load towards this, yeah, I didn't essentially, it didn't drop like so much. Like I think, was it 20% or something at most, and I could even optimize that. But yeah, like the core idea is that it was complete online upgrade. It was actually putting writes to this as well. So I don't remember, was it like 1,000, 2,000 requests per second, SQL requests per second that were actually writes to the database, and they all went through. There were no like problems with that either. So like I just did one change of like, I want to now have this version of that version. The operator sees the difference, starts rolling it out in a best practice way while serving consistent reads, consistent writes at 60,000 requests per second. Of course, you could go even further than 60,000 if you tune the hardware and all of this hardware was graciously donated by UpCloud, so I used some virtual machines from there. So on their Kubernetes thing. So yeah, I think it's pretty cool. I like it's Apache 2 license, so I highly appreciate that as well for both projects. Any other questions?
You mentioned the term operator a lot on this presentation, and I feel like operators are a great pattern to manage software, and especially databases and stuff. But the only problem I face with operators is that the operator is only as good as the person who wrote it, essentially. because like every time I face some new software, I want to get a feel of it, and I find a Kubernetes operator for it. For example, I mentioned here like publicly Elasticsearch, and I find a Kubernetes operator for it, and I wonder, how good is this written? Like, can I trust this? Do you have any like standard procedure to find out how mature some operator is? Or is it worthwhile to consider using a production cluster, or is it just garbage basically? Like any tips to essentially audit the operator?
Yeah, so the question was how to know how good an operator is without reading all the code. And I mean, of course, there's no super great answer to the generic answer to that, which would cover all of the cases. But what you can do, and of course, the operator is only as good as the person who wrote it. But what you can do is at least identify some, like in this case, 5. I quite like these kind of levels. So at least this you can identify quite quickly from the operator and its description. So what can it do? So the most basic thing is like install the database once, for example, and that's it. And then, like, if it upgrades, it would just, could maybe upgrade it, but it would just rewrite the thing and take down the cluster for some time. I mean, that would be the level 1. And then that's not because the operator couldn't upgrade it seamlessly, just because the person didn't implement it that way. Level 2, then we actually get the seamless upgrade. So for example, that's what I showed in that's the demo I did. That is, how to say, where in order to, when people talk about operators normally, that is kind of what is least expected. Like that is generally like what really you should have done for sure in order to call yourself an operator. But then going to the full life cycle, that's less people that do it, but still quite a lot of them, the TIDB operator does it. So then you have all kinds of life cycle, storage automated into it, backups, restore, snapshots, these kind of failure recovery. That is really nice. Then when you get even more, you get the metrics, alerts, log processing, all kinds of analysis. This also the TIDB operator does. I would say the only thing that is kind of more, it can maybe do, but it's still in kind of alpha phase, is the autopilot phase, the level 5, where we get horizontal, vertical scaling, all these kind of auto-tuning of configuration parameters based on what you actually, what is actually happening. So it would, in the car example, it would be that it would actually, when it's winter, then it will actually change the tires for you without having to kind of change in configuration that instead of having a configuration knob which is like tire type winter or summer, then it would actually have some tire policy auto switch or something like that, auto change. That is the autopilot thing, and few operators are there. There are a couple, but yeah, this is like, and this is actually on the operator hub. I think it should be for most of them at least given a guideline, but then sometimes I guess that the person that did the operator actually also submitted this, so you know how well it then is, yeah, for you.
Yeah, I think this is a good visualization because it really does, for me at least, drive home the point that developing a good operator for a stateful system especially is not a trivial task.
No, yeah.
It's a whole lot of code and edge cases that you have to take care of. But do you think there's particular boundaries to the operator model? Like, is there, what in a software system would you not model as CRDs and with the operator pattern?
Yes, that's a great question. So what would I not model with an operator? Anything that has a cardinality change, or like a rate of change that is requiring, say, hundreds of milliseconds or milliseconds or even sometimes seconds level of granularity or tens of seconds. If you have something that needs to react that fast, then I would use some other model, like, I don't know, sub-event queue or something like that. And probably I would use a lot of the similar kind of ideas and some of the core stuff, but then if you have that great rate of change, you would probably need to, in some of the APIs, change some of the assumptions that indeed were made that for most so when I said almost any infrastructure, infrastructure kind of tends to change in, say, minutes or hours or days, not milliseconds. But if you have milliseconds, then you need to tune some of the assumptions made for sure. So that is one case I wouldn't, at least today. I mean, maybe it would be a fun challenge, you know, that I might take up in the future to kind of prove myself wrong on that. But yeah, for sure, that would need changing in the core. Yeah, I saw that the pizzas arrived now, I think. Or is there still more coming?
Yeah, some more are coming, but I think some can already start.
Yeah. Okay.
How
Well,
are missing pizzas? Yeah, coming.
yeah.
Who's the pizza operator?
Yeah.
Who wrote it? Yeah.
Any more questions, or do you want to get started?
One more question.
Okay.
As this artificial intelligence is now nowadays the big topic, so has there been already some projects which utilize AI as an operator in Kubernetes?
Yeah, has there been any AI-backed operators or inspired? One funny thing I know is that is one, but I think it's more a CLI tool, but I mean it could work as an operator as well, which is taking, I think, the pod JSON definition, which includes both the desired and actual state, and maybe some other resources as well, pipes it to ChatGPT and ask what is wrong. And then you get some, I mean, pretty okay. I mean, mostly it's based on Stack Overflow. So like, and there is only, I mean, there's many good answers there, but for like not all of the edge cases and logic is there. I'm not sure if there's anything that actually takes a look at where you would actually feed all of the kind of training data of good and bad Kubernetes deployments and then label them and do training on, for example, like this, these types of workloads. I haven't seen anything do that. So like, instead of telling it to upgrade in a certain order, you would kind of give it so much training data that you would say that this is bad when it went down, like QPS dropped to 0, bad, and then just hope that it kind of turns into a secret. I haven't seen that, but that would be quite fun as well. Okay, Pizzas is here. We'll take more questions in the general discussion. Yeah.
The tool you mentioned was the K8s GPT.
Yes, Kate. Yeah, Kate. That's the one. Yeah. Thank you very much.
audience. So I'm kind of feeling now a little bit relief about that.
You can keep it a bit closer.
Okay, yeah, it's my first time. Hello, also to the TV over there. Also first time there. Yeah. By the way, who's familiar? Who's familiar with Backstage? Okay, yeah, I see a few hands there. I just want to know, like, how much do I have to explain? And who has Jenkins in his premises? Okay, and the question there is why? All right. So yeah, my name is Luis Laredo. I'm from Mexico. The only thing that you should know about me is that I am really bad speaking in public, especially in meetups. So please, now you know. I'm gonna talk about developer experience and what's Backstage role in developer experience. So no Kubernetes talk, at least now. So that's good, right? At least we have like a small rest of it. Well, yeah. So 23 minutes. 23 minutes. I should say that last year I was kind of obsessed with that number. 23 minutes is the time it takes for our brains to refocus after we have some distraction. So that's actually some study of this doctor of the California University, Irvine California University. She's named Gloria Mark, and she did this study. So yeah, I guess this number was important to me because, you know, I was kind of imagining football player, for instance, how it should be fully focused on the game, right? It can't have any distractions, especially if it's a final or something like that. Or musician. So if he's playing in an orchestra, he can't get any distractions whatsoever. Even a surgeon, or especially a surgeon, imagine that you are in surgery or something like that, and he has like this Instagram notification. So what would happen? Like really bad consequences there, right? Luckily for us, that's not our case. Like, what's the worst thing that can happen if we get distracted? So for most of us, it could mean only maybe more stress, because probably we will have to speed up our work to compensate that time that we are spending while being distracted. And we could have less energy as well, because the fuel, which is glucose, that releases the brain, or that burns the brain, to be focused, to be fully focused, is the same fuel that we need to do these other tasks when we are distracted. So by the end of the day, we can end up exhausted and not have been like really productive, or not feel like really productive at all. And I guess that's not good, right? But I mean, that's our job. That's part of, or that's the nature of our jobs. We have to be in front of a computer. We have to read through documentation. We have to go through different platforms to different tools. We have to search for libraries, for dependencies. So we have to use pretty much internet all the time. And to me, one day of work, it just started looking like this. Like I had some time when I was working, or where I was working, and then I just had like this small distraction over here. And then I had to go back to read the code and, you know, to know what was the last thing that I did, and then work for a little bit longer, and then get another distraction, like maybe, I don't know, an email notification or a Teams message or something like that, that I have to be looking at. And then go back to work, and then another small distraction, and then again go back to work. So by the end of the day, my chart was looking like that. And I had all these gaps, right? And in all these small spaces, I was thinking, okay, what am I doing? So it started to feel something like this, like meaningful actions getting lost or were getting lost between all these gaps. And if it's a day, that's not important, that can happen. But if you start adding day after day after day with all these little gaps, you start thinking about your life and how much time of our lives are getting lost in those small spaces. So it starts to matter, because then you start to feel like you are losing your life in those gaps, which are not kind of time to rest, like consciously time to rest, but they are just distractions. It's just scrolling over social media. It's just like replying that message. It's just watching for the 5th time our email. And yeah, it really starts affecting how we feel, maybe in our work environments. So when I joined OpenText, I was wondering if actually there were like similar things happening company-wide, right? If there were something similar happening with other developers. So I talked to my boss about this, and he told me, okay, well, let's find out. Let's do interviews. Let's do focus groups. So I did that, right? I did also guerrilla research. And I started getting a lot of feedback from other developers, from other engineers. And that feedback was pretty interesting. I tried to condensate, to put the feedback that I gather in these 3 main points. So what I found was that in the company, there was software and documentation fragmented into different platforms. Okay, yeah, someone laughed. Yeah, someone felt identified with it. Also, engineers were dealing with too many different technologies. And simple things were taking a lot of time. So I went back to my team, and I told them, okay, this is what I found. And they said, okay, well, let's start finding a solution for it. So we started brainstorming, and we end up with something that we wanted. We didn't know exactly what we want, but we did know that we wanted something with at least 6 elements. And those elements are some solution that could be auditable. So we wanted a fully audit on any change made to the system, and that was giving us Git this functionality. So we wanted this Git integration, also declarative. So we wanted to focus on the what and not in the how. We wanted to do non-trivial things in a trivial way. We wanted a single source of truth. So we wanted a one-stop shop for all the operational information that could be close to the developer's code. Also community-driven. So we didn't want to reinvent the wheel. We didn't want to build something from scratch. We only wanted battle test technologies adopted by the community. And self-serve. So we wanted independent developers. We didn't want it to be bottlenecks for other teams. And visibility. We wanted to have a complete overview of our system. So which resources we had, which dependencies, and ownerships. So, okay, we started finding or looking for solutions that could have like these different characteristics. And by the time, Backstage was getting more popular. At least it was getting more popular in the CNCF community. So we decided to try it. It just felt like natural to us, to the things that we were looking, right? And I'm gonna tell you why it felt natural. So Backstage has this triple approach. They basically are saying to you, okay, if you have a developer problem, the ones that you have identified, then you need to be sure, you need to ensure that you are creating the right resources for your developers and to try to automate that as much as possible. And also, once you have that, you have to ensure that you have full visibility of those resources and that you can manage them, that you can use the same tools from a single place. And finally, if you have all this documentation that is fragmented, and the same happens with software, then you should be able to access that information from a single place, because that is going to make the onboarding process for new engineers much easier, much simpler. So we decided we like it, this little tree domain idea. And we said, okay, let's try it out. Let's see what happens. How do we do that? Okay, so we are going to use this Lean UX approach. And I don't know if you are actually familiar with Lean UX. So it's kind of like this UX methodology that it's very similar to UX traditional methodology, where you have to do this user research, and then you have to create something, and then you test it, and then you learn from it. We have heard this in so many different forms, right? The only difference with Lean UX is that you don't produce so much documentation in the process because you are working really close to the developers, which are in this case our final users. So we are getting continuous feedback from them, and they get also the information that they need. So this information is traveling all the time. So we don't need to create that much documentation. But we had everything we needed to start trying it out. We have an assumption. So we had a clear problem, and we said, okay, we think that this tool can solve this problem. So we are going to try it out, and that's our assumption. We are going to build this prototype with these 3 different domains. We are going to test it, and we are going to learn from it. So that's what we did, once again. We took the project that, as Lucas said, is in GitHub, like many of the projects of CNCF. And we divided the project into two local repositories for us. So one repository had all the configuration of Backstage, so meaning the users and the groups. The other one had like this core project with the pipelines to deploy it into the different environments. And we use Helm to deploy it, so it was a Helm chart. And we deploy it in a Kubernetes cluster because, of course, CNCF, right? And we were monitoring all the databases with pgadmin and authenticating the users with Azure. But still, we needed to kind of know how to onboard all the development projects that we had, and they were quite many. So then one of our team members, actually Oliver over there, thank you, came out with the idea and actually built this Go tool that takes the metadata of every repository, so all the information that Backstage needs to register a project into the software catalog, and creates a merge request to create this catalog info file. So it puts this file in the repositories. And then once the merge request is merged, Backstage registers the project with a processor that it has, and that is all the time scanning the GitLab repositories in this case. So yeah, that worked well. That helped us to add like all the projects that we had in maybe just a couple of days. So it was a really good and big contribution. Yeah, of course. I forgot, you know, I'm really bad at speaking in public, to mention what Backstage is actually. So it's an internal development portal. So that means that it's kind of like a web page for your development teams. And I don't know if, who hasn't seen like the interface actually of Backstage? Okay, a lot of people. Okay, now I have to pause the talk to show maybe what's the interface of it. So basically, this is like the main page. Well, let's call it the software catalog page. And you have here all these kind of entities. And every entity has like different tabs. And in these tabs, you have like a whole plugin ecosystem over here. And you can have like different components or cards that show different things, like for instance relations and this kind of about pages and components and subcomponents. And you have an API page as well, so you can try your APIs in there. And you have also this docs page where you can check all your documentation. And right now it's not working because, you know, live. And you have this template thingy over here. So that's really cool because what you can do is to use scaffolding actions to create, to take code and then just fill it with the information that you want and put it on another repository. And you can have like other kind of plugins like this tech radar that shows like the technologies that you want to adopt or you want to get rid of or you want to assess or try. So it's a very flexible tool, and you can have like this thing in your within your teams, and they then start like using it, like all the functionalities that I was telling you about, and it kinds of speed up the process. So that's the whole idea, right? And that was what we're trying to find out if it was working or not. So I'm gonna go back to the presentation. I was mentioning a while ago about documentation. So Backstage handles the documentation in an interesting way. They had this concept called docs as code. What it means is that they have this TechDocs CLI tool, that's the first rectangle over there. And inside you can find this router. So what the router does is to scan the repos, and if there's something that it's like a markdown file and can be converted into a web page or a document page that you can use, it takes it and then it prepares the markdown file, then it generates the documentation that you want, and then it publishes it locally or on the cloud. So that's like how this tool works. And if you have already like the documents are already like created through this process, then it's just going to like fetch the documentation and display it on your UI. But what is really interesting about this is not the actual tool, but the approach. So docs as code. What it means is that you are going to start managing your documentation the same way that you could be managing code. And that means that you can start having tests on your documentation. So we install this Bailey tool. And what it does is it checks for spelling errors and the format of the documentations that we are currently using. So we can standardize all the documentation we have, and that kind of also speed up the process, because if you are reading always the same kind of structure, then you know what you can find in there. Also, Backstage, as I mentioned, it's kind of this portal where you can have different components. So it works actually the same way as Kubernetes. I'm sorry, I couldn't stop mentioning. Yeah, I couldn't resist. What I mean is that in this case, you have also declarative definitions, and you have all these different plugins. No? And for instance, we have this scorecards plugin, and this docs plugin, and GitLab plugin, and New Relic dashboard plugin, and QA reporter plugin, JFrog Artifactory plugin, Kubernetes plugin. I don't know. There must be hundreds of plugins right now. If you go right to the backstage.io page, you will find out like all the plugins that they have in there. And it's also really easy to create your own plugins. So you just use one line of one command, and it creates kind of like a bare-bone structure of the plugin. And then you just like kind of start editing what you want. So what we did is to create actually this QA reporter plugin, which is like an at-home plugin. And what it does is that it, what this actual plugin does, it downloads the reports, the test reports that we had through different testing tools like Robot Framework or I don't know, SonarQube or Playwright. And it processes, so we can have like the same kind of structure, and then you can just like retrieve the results from there, from any kind of testing tool. So that was very helpful also for our developers. But you know, after trying all these things, we have this question: well, did it work? Did all this, I don't know, 6 months of work actually help for something? So we start thinking like, okay, how can we test that it works? We didn't want it to use like these DORA metrics to check if it will like the productivity of the developers. We wanted to actually test if there was some better experience. So what came out was to create this A/B test. So basically, we divided all the engineers into groups, and in one group we had people working with Backstage, and in the other one we had people not working with Backstage, working the same way they were working as always, right? So we start assigning tools, tasks for each one of these domains that I was telling you about. So create, manage, and explore. And started like observing how they were performing the tasks. And after that, we had some interview with those to ask them about their experience. And after we gathered all the information that we needed, we created this little chart. So in the manage and explore categories, Backstage was very useful. And in the create category, something particular happened. So we asked them to create a project from a template that we had created with Backstage. And we found that it was kind of difficult for them to know how to use it. So what we concluded was that our template wasn't good enough. So the next step was to actually try to improve it. And it's almost over, I promise. So basically, we just said something like, okay, if we had like this static code that we want to use for our templates, we can try different things, maybe AI or something like that. So let's use some open source AI or something like that. And that's something like work in progress right now. So we haven't had any results. But it's the purpose of it. It's use again this lean UX cycle and then get again feedback from it and then keep just working on this idea. And yeah, so closing remarks. We concluded that Backstage show strong capabilities to improve our development team's developer experience. Continuous feedback was crucial in this journey to push forward DevX and open initiatives. And open communities play an essential role in shaping the development ecosystem that we as developers need. So as the last bullet says, open communities are essential. And open communities are the ones that are shaping the company's future and the developer's future and our own future, if we want to see it like that. So thank you for joining this community. Thank you for being part and contribute to CNCF. And thank you for working for the future of developers. Thank you. All right.
Is it in production now? Have you implemented this?
Yeah, locally here in Finland, we have implemented it and we are working with it. And now we are thinking in using it worldwide because it had this really good reception. So we are now moving it to be used by other countries as well.
I think referencing a little bit of a classic like XKCD cartoon is that if you have 5 developer platforms and you have bring one that replaces all of them, now you just have 6 developer platforms. How do you get that like buy-in from everyone else to now use this specific one? They've had years and years of using these other ones. Now we need to shift all of them to this new one.
Yeah, that's a really good point. Actually, I came ahead of you. I have my own XC cartoon in there. Yeah. So yeah, that's obviously something that we don't want, right? And that's why we need this continuous feedback, and that's why we need to have like really solid basis that we're actually trying to define from the start. So now the initiative of the organization is to just push forward what we want and try to use as much as possible the different functionalities that it has. So we don't know what will happen in the future. Yeah, if something better comes out, probably we will change. But for now, this is what we have found, and we think it's quite good.
Yeah, I think all the data is very important for executive level buy-in as well, because a lot of it comes from top down.
Yeah, and definitely there needs to be management support in that sense. Yeah.
So did you have actually any alternatives to Backstage?
Yeah, there are some commercial alternatives. There was actually one that it was marketed like something like Backstage, but without configuration or something like that. So we take care of that. So that's how popular Backstage is becoming. Backstage is actually a project that was was created by Spotify, and then it was adopted by different companies. So what we wanted to do is these paddle test technologies that were like actually being adopted, and the contributor space, it's quite big right now, and it's still growing, and the pace that the project is having, it's quite also fast in that sense.
So, but according to your 6 requirements, that's the only project that fulfills
The only that
them. So
I remember right now. That's why I can't tell you about the other alternatives, because I didn't like kind of run that analysis, but someone else from the team actually made this I don't know, benchmarking, analysis. Yeah. Yeah.
Is Backstage still managed by Spotify like centrally, or is there some collaborative foundation?
CNCF.
CNCF.
Yeah, it's managing Backstage at the moment. Some other question? Okay, yeah.
Did Spotify have some like commercial plugins, or what was it like? It's not totally free if you use everything? Or?
Yeah, that's actually a very good question. So how Spotify make money from their project? Why they did open source it, right? So that's their model. Actually, they are selling these commercial plugins. They open source the whole project. So the project is actually maintained by the open source community. But if you want some of the configurations that they already have, because they have been with this project for much longer than the project is in CNCF, you have the option to buy the plugins and make things simpler. Yeah. Okay. Thank you so much.
Thank you.
Yes, thank you, Luis. That was a good one. So I think we will now run to the next one. So Christoph, please, security-related topic. And I think it's not anything super secret, but this is not going to be recorded.